Section 5.4, okay, you guys will be able to, on Tuesday the 19th, apply properties of systems of linear equations to real-world scenarios, okay? So, in Section 5.1, we learned how to graph two equations at once and say, hey, the solution is where they intersect, where they touch, okay? Then we have where they didn't touch, where they're parallel, and they were no solution, where they're the same line, and we call them coinciding, and that was IMS. Then in Section 2, we learned to solve them by substitution, where we had to get a variable by itself, plug it into the other equation. Okay. Then we learned in Section 5.3, the one we just checked over, elimination. Okay. That was the one where we had to get everything lined up. We eliminated a variable, hence elimination. Okay. So now, those were our three methods that we learned for solving these systems. Okay. Now we're going to start applying these a little bit. Okay. Which tends to mean word problems, okay? So we're going to apply these to more real-world scenarios and see some tangible spots of this, okay, where this could actually come into effect here. So our first example, Jenna is deciding between two cell phone plans. The first plan has a $50 sign-up fee and costs $75 per month. The second plan has a $30 sign-up fee and costs $80 per month. After how many months will the total cost be the same, and what will the cost be? Guys, this is like a real scenario, okay? Signing up for cell phone plans, shopping around, finding the best deal. Sign-up fees, or a lot of times they're called activation fees or line startup fees. Whatever, different companies call them different things. And you have your different monthly costs, okay? So this is a very, very real scenario. Now, what's a good first step I encourage on word problems? Okay, Courtney?
To go through and circle or underline important numbers.
Yeah, underline, circle, highlight in some way important information, whether it's numbers or words, whatever it might be, okay? So who has something that might be important here, good for us to know, okay? Abby, what are you thinking?
Sign-up fee.
Okay, the fact that it has a $50 sign-up fee is probably good to know. Okay, Courtney, what else is good to know?
$75 per month.
Okay, it costs $75 per month. That's probably good to know as well, right? Okay, who else has something, Brady?
$30 sign-up fee.
Okay, next one has this $30 sign-up fee. Okay, what else might be good to know here? Okay, Jack, what's something that might be good to know?
$80 per month.
It costs $8 per month, right? Okay, is there more information that's probably good for us to know? Okay, the fact that there's a first plan. What else? Probably then there's a second plan as well. Okay, now what's this actually asking? What's the question we're trying to answer? Okay, how many months for the cost to be the same, right? Okay, and what else do we want to know? What will it cost? So like what cost? Okay, so we want to know. Personally, I would say this kind of covers our important information. We know I have a first plan, $50 sign-up fee, $75 per month. Second plan, $30 sign-up fee, $80 per month. We want to know how many months for the cost to be the same and what that cost is. Okay, so this kind of narrows us in and kind of helps us focus on what's important here. Now, how many equations do we think we're probably going to have? Two. Why do we say that?
Because there's 2 plans.
Because there's 2 plans, right? And how many equations have we been dealing with all chapter? 2. So probably it's going to follow a theme here, right? That would seem to make sense, okay? So we do have 2 plans, and we've been dealing with 2 equations all chapter, okay? So we're going to be doing 1 equation per plan here, okay? Does anyone have an idea of what one of the equations might be, okay? Abby, what are you thinking?
75x, because that's per month.
Okay.
Plus 50, because you have to add the sign-up fee.
Okay.
Equals y.
Okay.
Y would be how many months, right?
Okay. So I actually super love this a lot, okay? I would just clarify one thing you said there. So $75 per month, okay? So what variable is representing months then? X. So it might be a good idea to write that in there. Now, could we also use M for months if you wanted?
Oh, yeah.
You totally could, okay? We don't have to. It doesn't matter. Plus $50 sign-up fee. Now, why is 50 not times X?
Because it's only a one-time sign-up fee.
Yeah, it's a one-time fee, right? You pay it once and you're done with it. Equals Y. What's Y represent in this scenario then? That total cost. Okay, after X amount of months. Okay? So I totally agree with this being the equation for that first plan. Seeing this, can somebody give me the equation for the second plan? Jaden, what are you thinking?
Probably 80x plus 30 equals y.
I would completely agree. 80x plus 30 equals y. Okay, same idea. $80 per month plus a $30 one-time startup fee is going to equal our total cost y. Now, we notice right now we have the total cost being the same. Here's why it's okay to do that, and here's actually why we have to do that. Because our question's asking, when will they be the same? So we need to set the costs up as being the same. So they won't be the same every single month. That's why we have this question. But at a certain time, after a certain number of months, they're going to be the same. And before that, one plan is going to be cheaper, and after that, another plan is going to be cheaper. Questions on how we got these two equations. Okay, now that we have them, we can solve these by any of our methods. We can solve by graphing, by substitution, or by elimination.
How does elimination work if it's not like the measurement?
Okay. If you think of it or have that question again later, let me know. Now, graphing. I can think of one reason why this might not be the best idea to graph it right now. Can anyone tell me what that might be? Okay. Okay. Bigger numbers might be harder to graph. Okay. It might be hard to adjust that. What else might be a good idea, Jaden? What? I don't want to draw a graph. Are graphs as accurate when we draw them versus when they're given to us? No. So if you're not given a graph, unless you want to pull out graph paper, it's probably not your best idea. Now, this one could be done on graph paper just fine. But we don't have a graph, and so it's not going to be as accurate. Okay, so that's probably a time to kind of move away from doing a graph. Okay, so we have a choice between what method we're using, and we're saying, well, maybe not graphing. Yeah.
So how does elimination work if it's not like, because like all the elimination equations are like x or like something x, something x, then plus something y, but it's not.
Yep. So we actually had an elimination like this for number 24 in our homework, where we moved the y or moved the x over, I believe it was, and then we had the x's alone on the right hand side. So it actually would work out very similarly to that one, but all the others were following that same format you said. Hey, Miss Caniglia. So I would say this one is actually set up very well for either substitution or elimination. Does anyone remember what setup we had to have for substitution? Look back in your notes to VD2. What setup did we have to have for substitution to work? We had to have a variable by itself. It didn't matter if it was x or y, but we had to have a variable by itself. Do we have a variable by itself? Yeah. So in that case, it is set up for substitution. Now, is this also set up for elimination since everything's lined up? Yeah, so we really have a choice, okay? Raise your hand if you want to solve this one by substitution. Okay, hands down. Raise your hand if you want to solve this one by elimination. Okay, a few more votes, okay? So we'll do elimination, okay? And then I'll go back through and do a quick substitution one. Emily, if you want to solve this one by substitution while we solve by elimination, you're welcome to as well. We should get the same answer, assuming we both do it correctly. So for elimination, we need to get either the x's or y's to eliminate. Which one's going to be easier to get to eliminate? The y's, right? They're already the same coefficient. So what do we need to do to these in order to get them ready, though? Make one of them a negative, right? Which one do we want to do, top or bottom? Top, cool beans. Let's multiply the top one by a -1 and rewrite it. So we're going to get a -75 minus 50, negative 75x minus 50 is equal to -y. And that bottom equation is saying the same. 80x plus 30 equals y. So now we add these together, and what's -75x plus 80x? 5x. What about -50 plus 30? -20, very good. And -y plus y? 0. So now we have this equation, 5x minus 20 equals 0. Okay, well, Alice, at this point in this equation, what would you do? Yeah, I think that's a great math move. Adding 20 to both sides there. -20 plus 20 is 0. And now we have 5x equals 20. So we have our x closer to being by itself. Okay. Isaac, what would you do now when you have 5x is equal to 20?
Divide by 5.
Yeah, divide by 5, right? Then we're going to have our x. And what is our x? 4. So what's that represent? 4 is the number of months, right? So we know after 4 months, the cost will be the same. What other question do we want to answer?
What's the y?
The total cost, the y. Okay? So here we need to plug it back into either of the equations. Okay? Which equation do you want to do, Jack? Top one, okay. So let's plug in this top equation. So we have 75 times 4 plus 50 equals y. Well, 75 times 4, that's going to be 300, plus 50 equal to y. So we end up getting 350 equals y. Now, what's the label on that 350? Dollars, right? So after how many costs will the months be the same? Or excuse me, after how many months, after how many costs will the months be the same? After how many months will the cost be the same? 4 months. What will that cost be? $350. So notice that we are answering this question a little differently than our ordered pairs. Because it's not asking us for an ordered pair necessarily. It's asking very specific questions with very specific labels. Okay? But we solve it the same exact way as we would with any other one. Emily, did you solve it by substitution?
Yeah, I got the same.
And you got the same answer. Very good. So if we solve this one by substitution, we get the same answer, okay? Real quick, what ends up happening, don't write this down right now, okay? But real quick, what ends up happening is you would take 75x plus 50. We would take all of this and plug it into the y down here. And so 80x plus 30 is equal to that. We replace the y with that, and then we solve this equation. So from there, you subtract 75x, subtract 75x. You get 5x plus 30 equals 50. Subtract the 20. subtract the 30, I said subtract 20. 5x is equal to 20. Does 5x equals 20 look any familiar to us at all? Yeah. Is that the same exact thing we ended up with before? So from there, we'd get x equals 4, we'd plug it back in, we get the same thing. Okay? So did it matter which method we use? No, it's all about which one makes the most sense to you and which one it's set up for. In this case, it was really set up for either. All right, Emily, I'm happy you did that one, so I had a good example of someone going through and doing that and getting the same answer. Thanks for doing that. All righty. Any questions on this problem? Okay, you guys killed that one. Proud of you. One cable TV provider has a $60 setup fee and costs $80 per month. Second has a $160 equipment fee and costs $70 per month. In how many months will the cost be the same? What will that cost be? Okay, underlying key information. Ava, what's something that you think is key information here?
The $60 setup.
Okay, I would agree. I think that's pretty key. $6 setup fee. Okay, Ellie, what else do you think is key? Okay, that it costs $8 per month, right? And I think that I like the part that you added, you included the per month. Okay. See, Sarah, what's important to you? Okay, the $160 equipment fee. Okay, equipment. Does that sound like a one-time fee or every month fee? Probably a one-time fee, right? For whatever cable box or whatever they're doing there. Okay, but most people don't get cable anymore, I suppose. It's all streaming services. Brady, what do you think is important here? $70 per month. Okay, I think there's maybe a couple more pieces of information we might want to see here. Eli, do you have any of them?
And how many months will the cost be the same?
Yeah, the question is asking us. We want to know how many months for the cost to be the same. Okay, and Josh, what else do we want to know? Yeah, we want to know what cost that is. Okay, what will the cost be? What does that look like? Okay. Does anyone think we're missing anything by chance? I didn't hear you. Okay, maybe the fact that there's one in a second, so that way we know we're differentiating them. Okay, that could be pretty helpful to us. Okay. Otherwise, I think we're pretty good. Okay. So, does anyone have an idea of how we might set up one of the equations for this one? Okay. Let's go, Brady. Go ahead.
80x plus 60
Okay.
equals y.
I'd agree with that. 80x plus 60 equals y. Okay. So x is representing our months again. And once again, if you want, you can make it M. You can make it D. You can make it Z. You can make a smiley face. You can make whatever you want, okay? So some people really like making these M for months. And some people like making it X because they're used to X, okay? And the Y represents our total cost, which you can make C. You can make T. But I'd stay away from T because it looks like a plus sign. All right, can somebody help me with my second equation? Okay, Eli, go ahead.
70x plus 160 equals y.
Yeah, 70x plus 160 equals y or m or whatever the total cost was. Okay, so whatever you called on yours is what we're going to call it on here, okay? And I agree with that again. So we have our per month fees with the one-time fees, whether it's a setup fee or an equipment fee. Different names, but they're both one-time fees that you just have to add on, okay? is going to be equal to the total cost. And guys, when you set up stuff like cable and internet, oh my goodness, there's all these one-time costs. They're all over the place. They're annoying. Okay, so it's a very real thing, and they all have slightly different names for them. Okay, any questions on how we got these equations? Okay, let's walk through our methods. Okay, so graphing was the first method we learned. Okay, this is in y equals mx plus b format, right? If we just flip the equation around, this is y equals mx plus b, which we like for graphing, but do we have a graph? No. Okay, so it might be a little bit tough to graph without a graph. Okay, so probably want to steer away from that one. Okay, is this one set up for substitution? Yeah, how do we know that? It has a variable by itself, at least one. In this case, two, but it has at least one. Okay, is it set up for elimination? Yeah, how do we know that? Everything's lined up in the same order as each other, okay? X constants equals y's, okay? So it's set up for either one, okay? We did the first one by elimination. So let's do this one by substitution. Let's just change it up, okay? But if you would rather do elimination on your paper, go ahead and do that, okay? You should get the same answer as long as we do it correctly.
What kind are you doing?
I'm gonna do substitution up here. Alrighty. So for substitution, we say, hey, all of this 80x plus 60, that's equal to y. It's the same thing as y. So it's going to get plugged in for the y. It's going to replace y. So I'm going to rewrite that bottom equation, 70x plus 160 is equal to y. But instead of y, I'm going to plug in the 80x plus 60. Now I have this new equation, and this looks like a a three-stepper back in chapter 2. So I'm going to subtract the 70x, get the x's together, get 160 is equal to 10x plus 60, subtract 60, 100 is equal to 10x, divide by 10, and x is 10, which represents the number of months. Yeah. So now what do I do once I know x? Plug it in, right? At this point, once you know one variable, whether you're doing substitution or elimination, either of those two methods, it's the same steps for the second variable. Does anyone have a preference of whether we plug it into the top or bottom here? Okay, top. Okay, so 80 times 10 plus 60 equals y. Okay, 80 times 10 plus 60 equals y. 10 replaces the x, does everything the x would have been doing, though, multiplying with 80. 80 times 10, we like multiplying by 10 because we just add a 0, don't we? So that's 800 plus 60 equals y. So that's 860. And what's the label on 860? Dollars. Labels are very important, okay? So to answer our question, it's going to be 10 months, and it's going to be $860. Now that means if you're going to keep a plan longer than 10 months, one of these equations is going to be cheaper. Does anyone know which equation would be equation or plan or company would be cheaper if you keep it longer than 10 months?
First one, second one.
Okay, I heard both companies. Okay, who wants to give me the reason first? Okay, Isaac, what's your reasoning?
10 months is the same, and then you pay less on one month on the second one.
Okay, so you pay less per month on the second one, okay? So after 10 months, you've already paid the startup fee, that's that equipment fee, and then every month after that, you're just paying 70. Versus 10 months in, you've paid the 60, but you're paying 80 now. So I'm going to agree with Isaac on this one, actually. The cheaper per month one is going to be the cheaper one after 10 months. Now, let's say you're only planning to have cable for 6 months. Which option would be cheaper, first or second? The first one, because it's a lower startup fee. Okay? So up until 10 months, the first one's cheaper. After 10 months, the second one's cheaper. Same thing can be said with the phone plan, okay? After 4 months, if you go longer than 4 months, you want to do that first plan because you pay less per month, even though it's a higher upstart fee. If you can afford it right away, you want to do that one. But if you're only going to have the cell phone for a couple months, maybe you're just visiting somewhere or something like that, like you're going overseas and you need like an international cell phone plan for some reason, for a little bit, then okay, just go with the bottom one maybe, lower startup fee, and you don't need it for that long anyway. Any questions on that?
No.
Okay, this is real world stuff, okay? It really is. Alrighty, yeah, algebra, okay? Alrighty, let's look at example 3 here, okay? Sam's a nice young man, okay? I'm saying this to man here. And it says his as well. So, spent $24.75 to buy 12 flowers for his mother. How sweet of him. Okay? The bouquet contained roses and daisies. Roses are $2.50 each. Daisies are $1.75 each. How many of each type of flower did Sam buy? Okay? Now, are we noticing, like, is this the same kind of setup as our first two problems? Is it saying, like, he's comparing to flower companies? No, it's actually a different setup. Okay, we're still going to have two equations, but these are going to look different, okay? So we're going to talk about how we have two different types of problems with these. The first two follow the first type of problem. This one's going to follow our second type.
This was on my math test.
Really?
Like this, yeah.
Boom, okay? We're going to take that math test next week, okay? We'll get better on this one. All right. Now, key information, still important to know. Okay? Raise your hand if you have a piece of key information for me.
Testing.
Okay, Abby. Okay, the fact that he spent $24.75, that's important. Okay, Courtney.
For 12 flowers.
Okay, about 12 flowers. Okay, 12 flowers. Okay, Alice. Okay, roses and daisies are the two types of flowers, right? Okay, Alice again. Or excuse me, Abby again. Okay, roses, $2.50 each. Okay, what else is good to know here? Daisies or what? Yeah, $1.75 each. Okay, Courtney.
You could do how many, and then you could put each type.
Okay, how many of each type? There we go. I like shorten it even more. Okay, how many each type? Okay, how many of each type do we want? Okay, do we need to know that his name's Sam? Do we need to know he's buying him for his mom? No, I mean it's sweet of him, but we don't actually need to know that for the problem. Okay.
Oh, and that R for roses and D for daisies.
Okay, and it does tell us kind of a hint. R for roses, D for daisies. That might be good to know. Okay, it's a little hint there. Okay, sometimes we will be given this, but it's saying, hey, instead of X, Y, this is the R and D. Okay. So we have this little table here. Okay, I'm going to have us try and fill in this table. I think it might help us. So it says use R for the number of roses. Do we know how many roses he bought yet? No, that's what we're trying to figure out. Okay, so for the number of flowers, and it's talking about roses, we can't put a number in there, but what can we put in there? R, because that's representing the number of roses. Okay, so what can we put in the daisies box for number of flowers? D. Now, what do we know about the total number of flowers? It's 12, so we can put that in. Okay. Ooh, I love it. Okay. And Abby's hypothesizing here we're going to have R plus D equals 12, okay? And I'm actually going to agree that that will be correct, okay? We're going to add up the number of roses plus the number of daisies, and that'll get 12 total flowers. Okay? Cost of flowers. For the roses, does anyone have a guess on what we're going to put in this first box for the cost of flowers? Okay. 2.5. Okay, do we need to put 2.50 or could we put 2.5? They're the same thing, okay? Now, is it 2.5 total for as many roses as you want?
No, it's times R.
Times R, because it's each rose. Okay? What are we going to put for the next box for daisies? Yeah, 1.75 D for every daisy, okay? So what's our total for the cost? $24.75. Okay, we're given that number. Okay? So in our first equation, we're saying, okay, we're adding these. R plus D equals 12. And notice I left some space in there on purpose, okay? Anyone have an idea of what our second equation might be?
250R plus 175D equals 24.75.
And that's exactly right. 2.5R plus 1.75D equals 24.75. Okay? So I want to quick talk about why we got these things, okay? Why it worked out this way. So in the first equation, we keep all the kind of labels together. Number of flowers plus the number of flowers equals the total number of flowers. Number of flowers, like quantity, quantity, quantity. How many? this bottom equation, cost plus the cost equals the cost. Cost, cost, cost. So we kind of kept like things together, right? We didn't mix the number of flowers with the cost in equations. We kept them separate here, okay? Whereas on the last equations, okay, everything was money, 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 money. Everything dealt with money. On this equation, though, it doesn't. Some of them deals with the quantities, okay? Now, a little hint here, okay, is if we see, let's look at how many labels we have, okay? Labels are going to be like $24.75, $24.75. Dollars is a label. Flowers is a label. Dollars is a label. Dollars is a label. This flower is not a label, though, because it's not on a number. Yeah. Does that make sense why this flower over here at the end would not be a label, but the other flowers would be? Okay, it's not with the number here. 12 flowers, though, it's labeling that number. It's saying 12 of what? Oh, 12 flowers. Okay? So, how many of these dollar signs do we have that are labels? 3. Whenever you have 3 of the same label, we're going to have a problem like this, okay? And it might even be a good idea to write that right at the top of this paper, okay? To put a little star maybe. I don't really have a lot of room there, but maybe put a little star and put 3 of the same label. Might be a good idea to write that in. So you have 3 of the same label here, okay? And exactly 3 $, $. And notice we put all of those together. Compare that to our previous examples. If you look through here, $, $2 signs, $3 signs, $4 signs. 4 of the same label. That's different, right? That's not 3. 4 is different. First one, $1 sign, $2 sign, $3 sign, $4 sign. 4 of the same label again. So when we saw 4 of the same label, it's going to be a lot different scenario than 3 of the same label. Are you guys kind of seeing that with the labels maybe a bit? Okay, I think that's going to be really helpful for us in figuring out what kind of setups we have. All right. Let's now actually work on solving this, okay? Okay. Is this set up for graphing? I'd say no. It's not in the right form, and we don't have a graph, okay? Well, that's our next method. Is this set up for substitution? Do we have a variable by itself? No, we'd have to get one, which we could, but it's not set up for it yet. Okay? Is it set up for elimination? Yeah, everything's lined up. Okay? So probably elimination is going to be our best method here. Okay? Now you can do substitution. You can graph. Okay? There's going to be a little more work on something like this where it's not set up for it. Okay? So for elimination, we would need to eliminate either the R or the D. What would we have to multiply by to get rid of the R's? Negative 2.5. What about the D's? Negative 1.75. Now, what would you guys rather multiply? Negative 2.5 or negative 1.75? Okay, I think most of us would say 2.5, right, rather than 1.75. Less decimals, less tricky. 2.5 versus like 1 3/4. That gets messier, okay? They're both not perfect, but that one's less messy, okay? So let's multiply by negative 2.5 on the top equation. So it's going to be a negative 2.5R minus 2.5D. And we're going to have to do 2.5 times 12. And we know it's going to be negative. Now we can always do that off to the side, okay? I'm going to erase that 3 of the same label note I wrote, just so that way I have room to write. Five times 2 is 10. 5 times 1 is 5, plus 1 is 6. Drop a 0. 2 times 2 is 4. 2 times 1 is 2. Add them together, 0, 0, carry the 1. Okay, we get, and one number behind the decimal, we end up getting 30. It's negative 30, okay? Here's another way to think about it. 2.5 times 12. Let's say someone's making $12 an hour. They work 2.5 hours. $30. Bottom equation is staying the same. 2.5R plus 1.75D equals 24.75. Now are you ready to add these two equations? I think so. What's negative 2.5R plus 2.5R? 0. Okay, now we have negative 2.5D plus 1.75D. We know it's going to be a positive or a negative. Negative. We know it's going to be negative something D. Now, this we might want to do off to the side. Or, here's the way I like to think about it. concession stand math. Go to a concession stand. Would you see $2.50 and $1.75 at the concession stand pretty often? Yeah, more than likely. Okay. What's something that might cost $1.75? Hot dog. Okay. And so let's say you go to the concession stand and for some reason you hand them $2.50. Okay. Instead of $2. And the hot dog is $1.75. What's your change? How much are you getting back? 75 cents. So, negative 0.75D. 75 cents, negative 0.75. Because the negative is bigger. Does that help anyone kind of think of it a little bit that way? Okay, good. Okay, I really like that. As soon as we put things into money, we're used to, hey, Mom, Dad, can I go to the concession stand and get this? Oh, how much do you need? Oh, I need this. Okay, well, bring me back the change. You know, that kind of stuff. Okay, we're a little more used to that. Equals, okay? Let's say you're buying a lot of stuff at the concession stand, okay? You're getting $24.75 worth of stuff at the concession stand. You're buying stuff for your whole family, okay? And you give them $30. You give them a 20 and 10, $30. You're getting $5.25 back. In this case, it is negative because the 30 is bigger, yep? So you're getting $5.25 back, but it's negative because the 30 was bigger. Very good catch there, Abby. Okay, and if that doesn't work for you, you can always do it off to the side, okay? We can always do the math off to the side. So now we are down to an equation where we have to divide by negative 0.75. Now I don't have any great money thing for this one except for you can say, well, how many times how many groups of 75 cents will it take to get $5.25? Or give $5.25. How many candy bars can you buy for 75 cents, you know? But that's really just still division. So you do 5.25 divided by 0.75. And what do I have to do with this decimal here? Move it, right? Move it 2, so I have to move the one inside 2 as well. So 75 into 525. We're going to be guessing and checking a bit here, right? Now, we know we want this to go in evenly, so we know we want the last digit to be a what?
6. Oh, sorry.
We know the last digit to be a 5, right? So 5 times what kind of numbers will end in 5? Will 5 times an even number end in a 5? Not only in a 0. So 5 times what kind of numbers will end in 5? Odd numbers. We need it to be an odd number, so we can narrow down half our options right there. Now, we can say, is this going to be, what would 10 times 75 be? 10 is an easier number to multiply. 750. So we know it's less than 10. It's an odd number less than 10. Does it look like it's crazy less than 10? Maybe slightly, but maybe not crazy, okay? What number do you guys want to try?
7.
Okay, let's try 7. Okay, so I'll go up here. I'll do 75 times 7. 7 times 5 is 35. 7 times 7 is 49. 49 plus 3, 52. Hey, it works out. So see how instead of guessing and checking 10 different things, we analyze it for a moment. We think about what do we want? What's going to happen here? What happens mathematically here? And we can save ourselves some time and effort on this if we think about it and go through it this way instead of just rushing into it. Now, you can also guess and check, and you can get there. See me, I put 525 up there. I need to put 7 up there, and 525 goes on here. All this to say, D equals 7. So how many daisies did Sam get his mom? 7. Now what else do we need to go back and find? How many of each type? So how can we go back and find the roses? Plug it in. Now, do you guys want to plug it into the top or the bottom one?
Top.
Right, easiest question of the year right there, okay? Top or bottom? Well, we're going to want the top one on this one, right? Okay. I'd be very surprised if anyone wanted to plug it into the bottom one, okay? You could. Hi.
Hi, I'm alive.
That's good. All right, so we plug it into the top one. R plus 7 equals 12. Subtract 7, and R is 5. So to answer the question, 5 roses, 7 daisies. Do these kind of get messy? Yeah, they do. Okay, Eli, what's up?
So if we know that there's 7,
Yep.
we got 7, 8, 9, 10, 11, 12.
Yeah, and so Eli's asking, Mr. Kossel, I can do, if there's 7 daisies, I can figure out how many rows there are in my head. Do I have to write that out? No, you don't have to, okay? If you know that in your head, Feel free to do it in your head, but this is just the actual math supporting it. Yep. Any other questions on this one? Okay, once again, the one thing I really want you guys to notice on this, okay, is the setup was much different than before, and it was all about how many labels we had, okay? It wasn't like a first plan, second plan, first company, second company. We had 3 of the same label, exactly, and so we put all of those in the same equation, and then we had our second equation, or our first equation that we ended up having to model as well, saying, oh, the number of this plus the number of this equals the total number. All right, let's go on to example 4 here, okay? This is our last example. Now, truthfully, I don't know whether to pronounce this name as Brianna or Brianna. We'll go with Brianna. Okay, good call. Brianna's family spent $134 on 2 adult tickets and 3 youth tickets at an amusement park. Max's family spent $146 on 3 adult tickets and 2 youth tickets. What's the price of a youth ticket? Okay. Underlying key information. Okay, Ava, what's something that's important here?
The $134.
Okay, so the fact spent $134. Good to know. Brady.
2 adult tickets.
Okay.
And 3 young tickets.
Okay, the fact there were 2 adult tickets, 3 youth tickets. Okay, I'll just underline the adult and the youth there, but you could underline the tickets if you want. Okay. What's another thing that might be important here? Abby?
Max's family spent $146.
Okay, we had Max's family spending $146. Okay. Okay, that's a different family. Okay, Courtney.
3 adult tickets and 3 youth tickets.
Okay, 3 adult tickets, 2 youth tickets. Okay. What else is important here? Okay, Jocelyn. Okay. Price of the youth ticket. Do we care about the adult ticket? No, we just need to know the youth ticket on this one. Okay, Eli?
Brianna's family.
Okay. Yeah, we probably know it's Brianna's family as well. Okay. That's probably important to know that it was a different family. Now, what else are you thinking, Abby?
I was going to say the equation like that.
Okay, you're going to say the equation. Before we get there, okay, let me pause, okay? Let's look at our labels again. Do we think this is set up more like our first 2 or more like our third example?
First 2.
Okay. Okay, Eli, what makes you think it's set up more like the first 2?
Because not a graph. Or whatever that
Okay, there's not the little table there this time, okay? We won't always have the table, but I do like the fact that, well, there's a difference. That's more similar to the first 2, okay? What was that?
2 equations that end up being kind of more similar to
Okay, so it looks like there might be 2 equations that are pretty similar to each other rather than 2 equations that are more different to each other, like we had in example 3. Is that kind of what you're saying? Okay. How many labels do we have here, okay? We see a $sign label, $sign label. We see how many $sign labels? 2, okay? We see adult tickets. How many times do we see that as a label? 2 for the adult tickets. How many times do we see youth tickets as a label? 2. Okay, we see it a third time as a word, but 2 times as a label. So do we ever see a label 3 times? No. For example 3, this kind of setup, you need 3 of the same label exactly. And then you'll do that one. But we don't have that. So that's a cue as well. Probably going to be more like example 1 and 2. Abby, you want to do the equation still?
yeah.
Alrighty.
2a plus 3y equals 134.
I love it. Can you explain that for me?
The 2 times the a is with the adult. The a is for adult.
Okay.
And then the y is for youth. So once we figure it out, then we multiply it.
Yeah. So A is for the adult tickets, Y is for the youth tickets. 2 times the adult tickets plus 3 times the youth tickets will give us a total cost of $134. Okay. Who can help me with the second equation? Okay, Courtney, go ahead.
3a plus 2y equals 146.
And that's exactly right, okay? Same idea here, but instead of having 2 adult tickets and 3 youth, it's flipped around. 3 adults, 2 youth, and it's 146. Now, do we notice that they both bought how many tickets in total? They both bought a total of 5 tickets, right? But one of them's more expensive. Just real quick, just random reasoning and logic here. Why might the second one be more expensive than the first one, even though they're both 5 tickets? They have more adult tickets, right? Which one's typically more expensive? An adult ticket, right? Wherever you're going, whether it's admission to a sporting event, some sort of play or musical or concert, whatever it might be, usually the adult tickets are more expensive, right? Okay, so that might be a good reasoning thing here, okay? So What method is this set up for right now, if any?
Elimination.
Yeah, I'd probably say more elimination. Why?
Because
Because everything's lined up, right? We don't have a variable by itself, and it's not y equals mx plus b, okay? And we don't have a graph, okay? So now for elimination, do we have to multiply the equations first in this one?
Yeah.
Yeah, we do, right? We have to multiply one or both? Both, unfortunately. Okay, Eli, you got the magic answer?
Times the first one by 3 and the second one by 2.
Okay,
Negative 3
okay.
and then positive 2.
Okay, so we want to multiply by a negative 3 and a positive 2. All right, let's do that. Now, which variable is this going to eliminate?
The first one.
The first one, okay? Now, Eli, did you do that on purpose, or was that kind of randomly that you decided to eliminate the first one?
It was just the first one.
Okay, just happened to do the first one, okay? I'll talk more about that in a moment, okay? So negative 3 times the first equation gives us negative 6a minus 9y equals negative 3 times 134, okay? That's going to be negative 402. Bottom equation is going to be 6a plus 4y is equal to 292, if I'm not mistaken. See, I'm double checking my math there. Yeah, I do believe it's correct. Okay. So let's go ahead and add these. Negative 6a plus 6a. 0. Negative 9y plus 4y. Negative 5y. Very good, Brady. Negative 402 plus 292. Okay. Negative, not 210. 110. Negative 110, okay? Subtract them. Stays negative. So now, what do we do to get y by itself? Divide by that, negative 5. And what do we get y to be? Not quite, a little bit more. 22. Taylor Swift would be proud. Now, 22 represents what? 22 is y. What's y? Price of a youth ticket. Now, do we need to go back and find the price of an adult ticket? No. This one we don't have to. On all the others, we had to go back and find the other answer. This one we don't. Now, what if we had gotten A? Would we have to go back? Yeah, so when I was asking, do you guys remember earlier when I asked Eli, hey Eli, did you eliminate the first variable on purpose? Does anyone realize why I was asking that now? Yeah, Alice. Yeah, because if we eliminate the first variable, it's going to be easier because we have to do less steps. We're going to have to plug it back in. But if you eliminate the second variable, you have to plug it back in. So that's something to also keep in mind as we go through these. What am I answering? And making sure to set yourself up for success on there. Now, is it the end of the world and absolutely undoable to go back and plug it in? No, we know how. But, I mean, if we don't have to. So to answer our question, it was $22 though. All right, any question on this stuff, guys?
is it not the bottom step?
Don't do number 4, 7, or 8. Don't do numbers 4, 7, or 8. Okay? Every other one we should be able to do. We could do those as well. But we won't do 4, 7, and 8.